In this discussion video, we'll do an example problem where we recognize sums as areas. So I'm going to look at problem number 8 from worksheet 13. And in our previous discussion, we did a couple of these problems already. But remember, the goal is I want to interpret the following as the area under a curve. So be sure to specify the function as well as the interval for which we are getting the area. So each of these limits of a sum represents the area under some function over some interval. And I got to figure out the function in the interval. So let's first recall how we wrote the exact area as a limit of a Riemann sum. So recall the picture was something like, if I have my axes and I draw some curve and I call this function y equals f of x, and we have some interval from a to b, we first split that up into n pieces. So I split this interval up into n pieces, and then I form rectangles using right endpoints. Okay, so that would look like this in the first subinterval, and the rest of these I'll do quickly. So there are our rectangles, and first we're going to add up the areas of these n rectangles, and I can do that in sigma notation. I'll get the sum from I equals 1 to n of something. I'm going to introduce some labels so I can write something in my sigma notation now. Okay, so I'm going to call this leftmost endpoint x naught. The next tick mark will be x1, and then I'll have x2, and I keep going until I reach b, which I'll call xn. Okay, the other thing that I'll need to know is, well, what's the length of one of these subintervals? So remember, we call that delta x. And our formula for delta x is it's the length of the whole interval, which is b minus a, divided by the number of pieces we're splitting it up into, which is n here. Okay, so we are going to be summing the areas of these rectangles, and the area of any of these rectangles has this base, which is delta x, times the height. And the height in general will look like f of x sub I, where I'm going to be subbing in numbers like 1 and 2 up until n to be these sample right endpoints that I use to determine that height. Okay, so far what we've done is we've added up the areas of these n rectangles, and now we're going to take a limit. Once we take the limit as n goes to infinity, we're now taking an infinite number of rectangles, and that will make this the exact area. Okay, so the other thing that I'm going to need to know to be able to handle these types of problems is how do we figure out x sub I? So the way I can figure that out is I'm going to first write out x naught, which is a, and then x1. x1 is going to be a plus delta x. A plus delta x. x2 would be a plus 2 of those delta x's. And if I keep going like this, x sub I would be a plus I delta x's using that pattern. Okay, so that's going to be x sub I, and I'm going to highlight that. That is x sub I. Okay, so now I want to do part F as a practice problem. So this is going to be a step up in difficulty from the ones that we did last time. I have this limit of this sum. I want to first give you 2 minutes to try this. It's almost definitely not going to be enough time to finish the question. I just want you to think about, how does this compare to my general formula for the exact area? And see if you can start to think about, what would it take to put it in that form? What is going to match up with what? So pause the video for 2 minutes to try it. 4, 3, 2, 1, 2-minute pause, and try this question. All right, so hopefully you paused it and tried it for 2 minutes. Let's talk about it together now. So we need something like, if I think about what delta x is supposed to look like, it's got to be some constant, b minus a, some constant over n. Remember, b minus a just represents how long my interval is. And that needs to be the delta x. So when I look at my function, I see this 3n cubed on top. It would be really nice. So I kind of want that to be, instead of 3n cubed, I'd like that to be 3 over n. I need a constant over n. Instead of that 3n cubed. Because if it's 3 over n, I could have like 3 over n times the rest of what I have, And now that's starting to look like a delta x times an f of x sub I, my function. Okay, so here's how we're going to do that. Let's rewrite our limit. We have the limit as n goes to infinity. All right, and the rest of it I just copy down quickly. So I'm going to multiply the top and the bottom of this by the same thing to turn the numerator into 3 over n. So to do that, I would have to multiply by 1 over n to the 4th power. So whatever I multiply the top by, I got to multiply the bottom by 1 over n to the 4th. All right, and now I'm going to focus on this part. So I'm not going to write the limit and the sigma in front. Let's just simplify this. So simplifying this, we'll get 3 over n on top. And on the bottom, we will get, if I distribute 1 over n to the 4th to the first term, we'll get 2, because the n to the 4ths cancel. And then to the next term, we'll get plus I to the 4th over n to the 4th. All right, so now I'm going to move that 3 over n to the front. And then that'll multiply 1 over 2 plus, and I'm going to rewrite the I to the 4th over n to the 4th as I over n to the 4th power. Okay, because when I look at what I have here, and I compare it to the general formula, let's zoom it out a little bit. Zoom it out a little bit more. So if I look at this, and if I think about my delta x, some constant over n, I'm seeing that here. So this makes me think, is that my delta x? And then if I look at the portion after that, my f of x sub I, that resembles this. Okay, so that's making me think that, oh, whoops, that circled thing, this is my f of x sub I. And if that's the case, I just got to make sure everything else sort of checks out. This would mean, looking at this, well, what's my underlying function f of x? Well, it seems like it could be, oh, and I need to know, well, what's the x sub I I'm plugging into that? So it seems like my underlying function could be 1 over 2 plus x to the 4th. But then you might be wondering, wait, where is the I over n thing coming from? Well, that's the x sub I. We are plugging in I over n into f of x. And when we do that, we get this expression, f of x sub I. Okay, so that's good. All right, so the next thing I want to do is make sure my x sub I sort of matches with the general formula for x sub I. So the general formula is it should be a plus I times delta x. So I can rewrite this as I times something. This is I times 1 over n. And if I look at that, well, this thing should be my delta x. And I don't see any a written here, any constant. But that actually tells me what a is, because there's no constant there. That means a is 0. But this does give me a problem. In the beginning, I said, wait, delta x is 3 over n. But based off of what we just have uncovered, our delta x seems to be 1 over n. Those need to match up and be the same. So there's a trick I can do to make sure that happens. I can just move this 3 to the numerator of this fraction. And if I do that, I'll get a 1 here, and now I am good. Okay, so from here, at this point, I kind of know, I know a, I know my function, I just need to know b. So that's going to come from my delta x, and I know, based off of this, that my interval length is the numerator, which is 1. Okay, so because I know my a value is 0, and we know that the interval length is 1, that tells me my b value. My right endpoint of the interval is going to be 1. Okay, so thus, this problem is the area under the function f of x equals 1 over 2, oh, oops, sorry. Ooh, I got to change my function now. Whoops, I forgot to change it over here. So my f of x should have been 3 over 2 plus x to the 4th. So hopefully you caught that earlier, but if not, we're catching it together. Because f of x should have been 3 over 2 plus x to the 4th. and then over the interval from 0 to 1. And that is our answer. So the moral here is when you do one of these problems where you have this limit of Riemann sums and you're matching it with a general formula for exact area, you really want to make sure that everything sort of matches up. Because initially here our delta x's were different, so I had to tweak my function and rearrange it a little bit so they were the same. And then that affected my f of x, so I had to make sure I then wrote down the correct f of x.